Hey everybody, we're working on some applications of exponent rules. Section 12.3, we're dealing with scientific notation. So remember last week we dealt with all those exponent rules. We had the product rule and the quotient rule and the power to a power rule. The negative exponents, which is going to be important today. Zero exponents and all these different exponent rules. Well, today we're going to be dealing with scientific notation. It's an application. It's how we can use some exponent rules practically. And it works really well when we're dealing with either really, really big numbers or really, really small numbers. Okay? In scientific applications, you often deal with huge numbers and small numbers. Things like the mass of a proton. The mass of a proton is a super small number. It's almost inconceivably small. And so we need a way to represent that without just writing a bunch of zeros after a decimal. In a similar way, like the distance between galaxies is a super big number. Like it's inconceivably big. And so we need a way to represent those numbers without writing out all the digits. And I mean, you could spend 2 hours just writing the digits of those numbers because they're like, hundreds of digits long. And so, so we need some simpler ways to represent those values. And so we've developed this idea called scientific notation. Now, the big idea with scientific notation is this. It's an idea that you guys already know or should know, and that is if you take any number, let's take the number 12 for instance, and multiply it by 10, any number times 10 is just that number with an extra 0 at the end, right? Well, what's really happening is if you think about this with a decimal, 12 with a decimal, 12.0, it moves the decimal over to the right one spot. Okay? And that's always the case no matter what this number is. If this was 5.25 times 10, well, multiplying by 10 moves the decimal one place right, and it would be 52.5. Okay? So multiplying by 10, I'll write this out, multiplying by 10 moves the decimal one place right. Okay? Multiplying by 10. Now dividing by 10 has the opposite effect. Okay, if I had 32.7 and I wanted to divide by 10, well, that moves the decimal one place left, and it becomes 3.27. Okay? And that works for any kind of number, whether it's a decimal, a whole number, anything. You divide by 10, it moves the decimal to the left. Okay, so dividing by 10 moves the decimal one place left. I apologize for my slightly sloppy handwriting there. I'm just trying to run through this quickly. Now, remember, division, it could be represented as a fraction, right? So that could be 32.7 over 10 instead of divide by 10, same thing. Remember, however, in the last section, last week when we dealt with exponent rules, if you have an expression, if you have a number in the bottom of a fraction with a positive exponent, 10 has a 1 power, a positive exponent, there's a rule for negative exponents that allows you to rewrite this. Instead of dividing by 10, you can actually multiply by 10 to the minus 1, a negative power. Negative powers end up being positive on the bottom. And so instead of dividing by 10, you could actually multiply by 10 to the minus 1. Okay, so again, multiplying by 10 moves the decimal right, dividing moves the decimal left. Dividing by 10 is the same as multiplying by 10 to the minus 1. These two operations are exactly the same. So, let's expand that. Let's say you had more zeros on this power of 10. Let's say you had something like 45 times 10,000. Well, 45 times 10,000 is actually 450,000, right? That's 45 with 1, 2, 3, 4 zeros. Yeah, 450,000. Okay, and essentially you've taken the decimal and moved it from between the 5 and the 0 all the way over here, which is another 1, 2, 3, 4 places. Notice it matches the zeros in our power of 10. But this is the same as saying 45 times 10 to the 4th, right? 10 to the 4th and 10,000 are the same thing. The number of zeros match up to the exponent. So the scientific notation is a notation that includes a power of 10, either a positive power or it could be a negative power, along with a decimal number. So scientific notation would have something like 5.24 times 10 to the 3rd. Okay, and so what we're really doing here with 10 to the 3rd is we're multiplying by 1,000, because 10 to the 3rd is 1,000, and that moves the decimal 3 places. So moving the decimal to the right 3 places. And this would end up being 5240, right? So from here you go 1, 2, 3 places over to get the decimal. So 5,240. If we wanted to do 1.33 times 10 to the 8th power, well, again, you move the decimal 8 places. So you get, and it's to the right because of positive power. So it's 1, 3, 3, 0, 0, 0, 0. Let me count this up. Starting here would be 1, 2, 3, 4, 5, 6, 7, 8. All right, so there's my number, and I need to put the commas in, so there'd be a comma here, that's 133 million. All right, so 1.33 times 10 to the 8th is 133 million. All right, so that shows us how to convert to scientific notation, or from scientific notation to standard notation. Let's say we wanted to go the other way. Let's do a big number like 87,000. So 87,000. Okay. If I wanted to convert that into the scientific notation, I would start my decimal on the end of the number, move the decimal until there's a ones place, okay, until the farthest left digit is a ones place, and that will give me 8.7 times, the zeros all can drop off because they're after the decimal, times 10 to a power. Now the power is the number of places it moved. 1, 2, 3, 4. 8.7 times 10 to the 4th. Okay. Now if I wanted to go the different direction and make these smaller, we could do that as well. And so we could use the negative power. So if I wanted to take, let's do 4.35 times 10 to the minus 5 power. Well, that moves the decimal 5 places left, because it's the minus 5 makes it really dividing by 10 to the 5th. And so division moves left, so we move that power, or that decimal left 5 places. You'd have 1, 2, 3, 4, 5. Now that's a lot of zeros. I need 1, 2, 3, 4 zeros. and then a 435. Okay. Again, this is a very small number because of how far it goes after the decimal. So moving left, to get a negative, to utilize a negative exponent, you move left that number of places. Let's try another one going the opposite direction. If I started with 0.00000003972, and if I wanted to convert that into scientific notation, then I got to move this decimal back until it lands right here so that there's a ones place again. Okay, the leftmost digit has to be in the ones place. So I want 1, 2, 3, 4, 5, 6, 7, 8 places. So that would be 3.972 times 10 to the negative 8. One quick way to remember whether it's going to be a negative power or a positive power is to say this. If your number is really big when it's in standard form, you use a positive power. If your number is really small when it's in standard form, you use a negative number. Okay? Negative power, sorry. Okay, so that should give you a pretty good idea of how to move the decimal. Again, making the number bigger when you have a positive power, and making the number smaller when you have a negative power.